Hey everyone, welcome back to your math class. And in today's lesson, we are going to be talking a little bit more about algebra. So we're still going to ease ourselves into the topic. So last time we talked about what algebra is, why it might be useful, and today we're going to start doing a little bit of actual math with it. Now, again, I still want to take it a little bit slow. Want to make sure you guys are not overwhelmed with all of these letters hitting you all at once. So we are going to take it a little bit slowly. We're going to take our time going through this lesson and the next one or two as well. But yeah, let's dive right in. So the plan for today is we're going to begin by reviewing what variables are, why they're useful, basically the things that we talked about last class. Then we're going to look at how to solve problems that have one variable in them. So I'm going to give you a mathematical expression. There's going to be a letter somewhere, probably X. I think only X I've used in this lesson, but in the next few classes, we'll start getting used to seeing some other letters in there as well. And then I'm going to work through a couple of simple examples. I think I've got two of them towards the end of the lesson where we're going to solve a couple of problems with one variable. Now, I think that should suffice for today. It might be a little bit shorter than usual. I'm not sure. Depends on how much I talk. Next class, we're going to do a couple more examples. So today we're going to review the basics, do some simple examples, and then next class we're going to review the simple examples. Maybe we'll do one or two new ones, and then we'll do some practice problems. So for me, my terminology, the words I'll use with you guys, and I try to be consistent. There will be times that I slip up, but generally speaking, examples are problems that I'm working through with you guys, right? So like I'm going to do the question on the screen. I'm not asking you to solve it first. I'm just asking you to pay attention to what I'm saying, maybe write down the same thing alongside and try to understand the process. So those are examples. Then there's practice problems, which are math questions like the examples for you guys to do that we'll check afterwards. So those are the kinds of questions where I say, here are the questions, pause the video and go for 5 minutes, work on those, and then we'll go through the answers and check how you guys did. And then there's also word problems, which I don't tend to do a lot of examples of. Now, as we're getting into the harder material, I will start to do example word problems as well. But then eventually we'll get to the point where you guys are solving algebra word problems without my help, and I'm just giving you the answers at the end of it. So that's the plan for this class and the next one. Let's jump into the actual math now. So a brief review, what are variables exactly? So variables in math are values, which are numbers. You might hear me say value, you might hear me say number, you might hear me say quantity. It's all the same thing. So variables represent values or numbers that are either unknown or that can change depending on the situation. So I gave you an example last class talking about the marks you earn on the test corresponding to the number of house points that you earn as a result. So like it was 5 house points for every mark you earn on the test. And so what ends up happening in that situation is you could say that that value is either unknown, the value being how many marks you earned on the test. If it's before the test is done or before the test is marked, that's an unknown number. We don't know how well you did on the test because it hasn't been marked yet. Or it's a situation where the value of the number of marks earned changes depending on how you're looking at the problem. So for instance, if I'm looking at all of your marks, then that's going to be a different number for each student, right? If you didn't all get exactly the same score, one student's going to earn more or less house points than another because they got different marks on the test. So that's what variables are really useful for. It's when you either don't know what a certain number is supposed to be equal to, and there's exactly one right answer that you have to figure out what it is, or it's something that it can change depending on the situation. So I'll give you an example here where it could change depending on the situation. So for instance, suppose you've got a recipe that calls for adding some cups of rice and some cups of water to a pot. It says that for however many cups of rice that you add to the pot, you should add the same number of cups of water plus 1 extra cup of water. So for instance, if you were to add 2 cups of rice, you should add 3 cups of water. If you were to add 5 cups of rice, you should add 6 cups of water. So something like that. And the recipe says, I don't care if you're putting in 2 cups of rice or 12 cups of rice or 212 cups of rice. When you put in the water, put 1 extra cup, right? So this is the type of situation where it could be useful to write this out in sort of a mathematical expression. So we've said that the cups of water that you should put in is going to be the number of cups of rice plus 1 extra cup of water, right? So if you were to write this out algebraically, to look like an algebra problem, then you could say W for water is equal to R for rice plus 1, right? Cups of water, W, is equal to cups of rice, that's R, plus 1, right? And so in this type of expression, it's not telling you, oh, you have to put exactly 2 cups of rice, or exactly 3 cups of rice, or exactly 1 cup of rice. It's saying, I don't care how many you put in. You might be catering for 100 people, you might be cooking for yourself. But however many cups of rice you put in, put 1 extra cup of water. So this is an example of a variable. And actually, we're going to talk about this in more detail, probably not in the next class, but maybe the class after that. We're going to talk about variables that depend on other variables. So they're not really like their own separate, completely unknown number. It's just that in order to find the value of one variable, you have to first find the value of a different variable. So in this example here, the W isn't a completely unknown number. It's just that in order to figure out what the W is, you first need to figure out what R is. And then once you figure out what R is, once you decide how many cups of rice it is, add 1 and you've got W. So we're going to talk about that a little bit later on. That's going to come in handy in our future units when we start to talk about linear functions and stuff, where you're going to have multiple variables, multiple letters in your expression, but one of them depends on the other one. So you only actually have to really put in the work to figure out one of them, and then the other one's just easy. You just plug in a number and you get your answer. So we'll talk about that a little bit later. Now, we're going to look at working with one variable in just regular old math problems, no word problems, right? Now, you've already actually done plenty of problems working with one unknown value. And the thing is, that unknown value is usually what you would have called the answer to the problem. So for instance, you'd have something like this. You'd have 3 times 4 plus 2.5 is equal to blank, question mark. I don't know, right? And what you're tasked with doing is figuring out what to put where this question mark is, right? That's the job you had up until this point in math, is that you're given an expression, you're given something like 3 times 4 plus 2.5. If it was a word problem, you're responsible for figuring out this expression, that from the words you pull out that, oh, okay, it's, you get 3 candy bars for every kilometer you run times 4 kilometers plus an extra 2.5 candy bars that you had, right? You pull this information from some word problem that's talking about candy bars, you build this expression, and then you need to figure out the answer. And that's a question mark until you churn through the math here, and then you get yourself an answer. The thing that changes with these algebra problems is that you still only have that one unknown number. It's just not all by itself on one side of the equal sign. So that's what I'm referring to when I say answer here, is it's just that one number that's by itself all alone on one side of the equal sign. It doesn't matter if it's the left side or the right side, but it's by itself. You just don't know what it is, and all the other information is sitting on the other side of the equal sign. So, for instance, this is a completely different question, not related to that one up there. For instance, suppose you have something like this. 5 plus something times 3 is equal to 17. Normally, if I'd put, for instance, if we were to swap this 17 with this question mark, then it would be 5 plus 17 times 3 is equal to blank. It's your regular old math question, right? You're just doing multiplication, addition, subtraction, whatever it is you need to do to get yourself an answer. And it doesn't feel like algebra because you wouldn't see any letters in there. You wouldn't see, any symbols besides like a blank line or maybe a question mark, so something like this, right? So what we have to do here is we have to figure out what number fits where this question mark is sitting. And there's a way that I'm going to show you that you can actually figure that out without just guessing numbers and see if they work. So let's look at that example, the one we just saw at the bottom of the previous slide. So 5 plus something times 3 is equal to 17, right? So first things first, if this is an algebra problem, we're not going to put question marks. We we won't. We're gonna put letters. I'm gonna put X in this lesson. If you want to write a different one in your notes, feel free, but you might get confused if you write down a B and then while you're copying me down, you start writing an X. So for now, I'd say stick to an X, but generally speaking, when you're working through questions, you can pick whatever letter works. Try to pick a letter that doesn't look like a number so that you don't confuse yourself. So like for instance, for me, this is just a little tip. A lot of you might write the letter Z like this, which is exactly how I wrote it my entire childhood. I thought this is, the best way to write the Z. It's the easiest way. You don't have to put any extra markings. But then as you start doing firstly more math problems, and as you get more comfortable with them, you start to write a little bit faster. Then you start doing algebra, and then you start doing algebra with lots of variables. So suddenly you've got X, Y, and Z in your problems, and you're writing them quickly. And what happens is those nice sharp edges on your Z's start to get a little bit rounded as you start to write faster. Your writing starts to get a little bit messier, and then now it's hard to tell apart that Z from this 2, right? So as a result, I started putting, whoops, I don't know why that happened. Let me erase that. As a result, I've started putting a line through the middle of my Z. Some of you have already been doing that, and that's great. For those of you that haven't, I'm not saying that you have to start putting the line through your Z. I'm saying it might help you not confuse a Z for a 2. And similarly for me, sometimes a lot of you will probably write the number 1 just like this. I always wrote my number 1 like this when I was a kid, like with a little tick here on the left-hand side. But then as you start to write faster and your hand's moving really quickly across the page, sometimes, that tick gets really, really pronounced. So sometimes there was a chance that I would confuse a 1 for a 7. So I started putting lines through my 7s as well. So that's just a little something that might help you. Later on in math, we're going to see something called absolute values, where you take, let's take a variable like the fancy curved X, and then you put 2 vertical lines on either side. And so now suddenly it looks a lot like a 1 if you don't write the 1 with a little tick mark. So I want you guys to think about that, not too hard right now, but just in the future, think about whether it's going to be easy for you later on to go back and understand what you've written. So I like to make my absolute value sign, which is just a vertical stick, look different from my 1, which has the little tick on the left side. Well, I didn't really draw that very well, which is different from the 7 because I have that line going across. So that's not part of the lesson. That's just advice to help you guys so that you don't confuse yourselves later on. But anyway, back to the problem. So let me get my laser pointer. Yeah, so first things first, we're replacing that question mark with the X, right? So now instead of question mark times 3, we've got X times 3. But remember, once we start using letters in our problems, we don't want to confuse this X with this multiplication sign. So we get rid of the multiplication sign entirely, and then we don't need the brackets anymore either. We actually never needed the brackets, but we're going to talk about that in a couple slides. So then I can rewrite this 3 times X as just 3X. No brackets, no multiplication sign, no nothing. And it's just there. It's a little bit simpler to look at this way, as long as you're not confusing the X for a multiplication sign, which again is why last lesson I suggested you write it in this kind of curvy way so it doesn't look like the times X, right? Now we've got to a manageable problem that we can start to try and actually solve, right? We've got 5 plus 3x is equal to 17. So 5 plus 3 times something is equal to 17. Now the most important rule, it's not really, maybe you could call it a rule, you could call it a process for solving an algebra problem, is isolate the variable. What does that mean? So isolating a variable means getting it by itself on one side of the equal sign. So you've got this whole big mess. You've got 5 plus 3x all sitting on one side of the equal sign. We want it to be just x is equal to, and then a whole bunch of numbers. And you can work with all those numbers. But if you've got 5 plus 3x is equal to 17, that's a whole lot of stuff going on the first side of, like on the left side of the equal sign. You have 5 plus 3x, that's a lot of things in there with the x. So we want to get rid of the 5, we want to get rid of the 3, and be left with just an x is equal to a whole bunch of numbers, and then we can do our calculation there because there's going to be no variables on that side. So that's just going to be pure addition, subtraction, multiplication, division. Now, in order to do that, and in order to do it properly, we first need to review BEDMAS. Now, you might have learned this as BEDMAS, you might have learned it as PEMDAS, you might have learned it as BODMAS, maybe there's even another one. And you might not have seen it at all. So we're going to talk about BEDMAS briefly because that's going to help you a lot when it comes to solving these problems. So here's what BEDMAS means for those of you who haven't seen it before. So the B stands for brackets. This whole thing is just a big acronym. The B stands for brackets. So brackets or those parentheses, it's the same thing. E stands for exponents, which we haven't talked about in this class. I'll probably do a lesson or two on them so you kind of know what's going on once we're using exponents. But that's where you've got like a little number written above a bigger number. So for instance, if you had like 2 with a little exponent 3, looks something like this. If you've ever seen something like that before, that 3 right there is an exponent. Now we're not going to worry too much about that in this unit because I want to focus on the variables, but then once we finish this up, or perhaps somewhere in the middle, I'll do a little video that's like, hey, exponents, here's what they are and how they work, and then we can do more complicated problems. So we've got brackets, exponents, then we've got division, multiplication, addition, and subtraction. These are the easy parts, right? Now I've color-coded them a certain way. So brackets by itself is one color. Doesn't matter what color. I've made it black, but doesn't matter that it's black. Just matters that it's the only one that's that color. Exponents also, it's the only one that's got its own color. Division and multiplication are sharing a color. They're both red. Addition and subtraction are both sharing a color. They're both green. Now the reason I've done it this way is that when you're working through a problem, what BEDMAS means is, if you've got this whole big expression, you've got 5 plus 3 times x is equal to 17. And even if there was no x, if it was 5 plus 3 times 2, and then there's brackets around something, and then there's an exponent somewhere, where are you supposed to start? Do you just go left to right? Do you do the biggest numbers first? Do you do the brackets first? What are you supposed to do? So BEDMAS tells you that if you've got this whole big long expression, you've got something in brackets or parentheses, right? You've got something in brackets somewhere, you've got an exponent somewhere else, you've got an addition problem near the beginning, you've got a subtraction problem over near the end, you've got division in the middle, you've got multiplication, you've got all this crazy stuff going on in your expression. This is telling you always start with the brackets. Always start up here with the brackets. So what do I mean by start with the brackets? I mean, if you've got inside brackets, if you've got 5 times 3, make that a 15 right now. That's your first step, is anything that's inside brackets. 5 times 3, write that as a 15 on your next line. Don't do anything else. If you've got another bracket somewhere else, 5 plus 3, make that an 8. Deal with everything that's inside brackets first, before anything else. Then move on to dealing with exponents. So that's this thing right here. So if you've got, well, we're not going to talk about exponents right now, but it's, if you've got something that's got one of these little numbers sitting kind of up top to the right, deal with that next. So once you've simplified all the brackets down to get just a number inside all the brackets, then deal with the exponents and solve all of these things, which we'll talk about later. And then after that, do all the division and multiplication. I don't care if the addition shows up before the division. Do the division first. That's what this is saying. That's what BEDMAS is telling you, is that I don't care if the addition and subtraction come at the beginning of the expression and the multiplication and division come at the end. Do the multiplication and division first. Now, between the multiplication and the division, the reason that they're the same color is between the two of them, it doesn't matter. Just go left to right. So if division shows up near the beginning, then you've got multiplication, then you got another division problem, just do them in order, left to right. You don't have to do all the division and then all the multiplication. You don't have to do all the multiplication and then all the division. Just left to right as you're reading through it. There's a division problem, there's a multiplication problem, there's another multiplication problem. I'm going to do all of those one at a time and solve that. And then once you're done all of those things, then you can move on to addition and subtraction. And it's the same thing as division, multiplication. Left to right, whatever shows up first. If the subtraction shows up at the beginning and the addition shows up at the end, do the subtraction first, no problem. And then by that point, there's nothing simpler than addition and subtraction, so you should just have your answer at that point. So that's how BEDMAS works. Hopefully you guys have seen that before and this was enough of a refresher. If you've never seen it before and you'd like more help, I should have posted other videos about it some time ago, but I'd be more than happy to help you guys out with that. If you'd like, you know, a one-on-one session or an extra video or something, just let me know. So now how is BEDMAS going to be useful when we go back to this example, this 5 plus 3x equals 17 business? So what we've got is this x is what we're trying to solve. We're trying to figure out what number that x is supposed to be, but it's stuck with all these other things. It's stuck to this 3 through multiplication, right? This is x times 3 right here. So it's attached to this 3 inside a multiplication problem. And then it's also attached to this 5 inside an addition problem, right? Because of this plus sign in between. So the trick to solving these kinds of problems, to isolate the variable, here's what you have to do. You have to follow the BEDMAS process from the last slide backwards, basically in reverse. So you're starting at the end. You're dealing with the addition and the subtraction. And if you see an addition problem here, you're going to do a subtraction. If you see a subtraction problem, you're going to do an addition problem. Now, I'm going to show you how that works. So we've got this 5 plus 3x. I'm going to write this on the side as well, just so you can kind of ignore the 17. We're just looking at the 5 plus 3x, right? So if I've got 5 plus 3x on the left side of the equal sign, the thing with following BEDMAS is you want to get rid of the addition and subtraction first, because we're following BEDMAS backwards. So now we start with the addition and subtraction. So we would really love to get rid of this 5. Now a great way to do that is basically you could rewrite this, because with addition it doesn't matter what order you write it in. This is the same thing as 3x plus 5. So if I want to get rid of that plus 5, I could just do minus 5. Right? Then it's 3x plus 5 minus 5. But the plus 5 and the minus 5, those are just going to cancel each other out. So this and this just disappear, and you're left with a 3x. So now it's a little bit simpler. The thing is, though, you can't just pull out a minus 5 out of thin air, right? You've got a whole other half of the equation to deal with, right? We can't just subtract 5 from the left side and like, okay, I'm all done. No, now you're changing the question. So if you're subtracting 5 from the left side, you also have to subtract 5 from the right side, because that way you're not changing anything. You took away 5 from this side of the scale, you took away 5 from this side of the scale, no problem. They're still going to be equal, right? But you can't just take 5 away from one side of the scale and then say, okay, I'm finished. No, no, no. These two things used to be equal. You've pulled one of them down here. You have to pull the other one down here as well. So if you're adding, subtracting, multiplying, dividing on one side of the equation, you got to make sure you're not changing the problem, right? It's very similar to when you're dealing with fractions and you multiply the numerator and the denominator by the same thing so that you're not changing the question. It's like that, except now we're doing it to the left and right sides of the equal sign. So subtracting 5 from both sides, we get 5 plus 3x minus 5, right? We're writing in that minus 5 is equal to 17 minus 5. So this left-hand side, we got the 3x is untouched, but then we've got this plus 5 at the beginning and this minus 5 at the end. Those two just cancel each other out. So we're left with just a 3x here. And then 17 minus 5 is 12. My mouse is not really cooperating, sorry about that. But yeah, 17 minus 5 gives us 12. Cool. Now we're looking at this problem, this 3x equals 12. Now remember that this 3x is multiplication, right? So if I write that out, we've got a 3x, and we want to turn it into an x. This is 3 multiplied by x. So if we were to, say, divide by 3, right, because originally it was x multiplied by 3, if we were to divide this by 3, then we've got 3 divided by 3. So these two cancel each other out, and we're left with just an x. But if we're dividing by 3 over here, we also have to divide by 3 over here. And so then you get 3x divided by 3, that's going to be just an x, and you got 12 divided by 3 is going to be 4. And then that's your answer. X is equal to 4. And at that point, you're done. One thing I would recommend to make sure that you didn't mess it up, just your own way of checking that you did it right, is take this x equals 4, put it in right there in the original, put it right there, so you make it 3 times 4, and then do your regular BEDMAS stuff. So we do the multiplication before the addition, so 3 times 4 is 12, plus 5 equals 17. So we've got 17 on the left side, 17 on the right side, and then you can be confident that you've done it right. So that's how the process works. So a couple of key takeaways here is, in order to solve for an unknown value that isn't by itself on one side of the equal sign, we have to isolate it. So we have to make sure that it ends up being by itself, and then we can figure out what number it's supposed to be equal to. Now we isolate a variable by following the BEDMAS steps in reverse. So instead of starting with brackets and ending with addition and subtraction, we start with addition and subtraction and end with brackets. And we also perform the opposite operation. So if you're dealing with an addition problem in front of you, to get rid of that number that's being added to it, you can subtract it off, right? So if you've got x plus 5 and you want to get rid of the plus 5, x plus 5 minus 5. And then now the plus 5 and the minus 5 turn into a 0. You don't have to worry about them anymore. Then you just have to make sure that you're doing the same thing to the other side of the equation. Now, once we get into some more complicated problems, you're going to see there's a little bit of an extra step where we have to do a little bit of rearranging before we can do any of the BEDMAS stuff, but this should suffice for now. So yeah, for instance, if you've got a variable that's connected to a bunch of other numbers through, let's say, multiplication and subtraction, we'll first perform addition to undo the subtraction, and we're starting at the tail end of BEDMAS, right? So we do the addition and subtraction first, and then we'll do division to kind of undo the multiplication, and then at that point we would be done. Now this can be a little bit tricky to get right, so let's do a couple of examples to round out today's class, and then if you guys have questions, absolutely let me know, and we will do more in the next class as well. So let's do a couple examples. So first things first, I don't need my laser pointer anymore yet. First things first, 4x plus 9 is equal to 25. So we need to figure out what the x is equal to here. Now, you might be really good at this, and you could just look at it and guess and figure it out on the spot that, like, oh yeah, it's going to be that. Maybe you can, but maybe if I gave you a little bit of a harder problem, bigger numbers, an exponent somewhere, that suddenly it gets messy. So you should still know how to do it. And I want us to work through it with a relatively easy problem, and then later on it'll get a little bit harder. So here we've got an x that's attached to this 4 through multiplication, right? There's a multiplication problem here. It's 4 times x, and then we've got an addition problem here, plus 9. So looking at BEDMAS, we want to do this in reverse. We want to start with any addition and subtraction that we have. So we've got an addition problem, so let's get rid of that plus 9 by subtracting 9 from it. Something like this, right? So we'll just write in a minus 9 on the left side, and then we'll also write in a minus 9 on the right side, because if we didn't do that, we'd be changing the problem. So now we've got 4x plus 9 minus 9 is equal to 25 minus 9. So if we look at just the left-hand side, 4x plus 9 minus 9, this whole plus 9 minus 9 is going to just become 0. So we're going to be left with 4x over here. And then on the other side, it's just a subtraction problem. 25 minus 9 is 16. So then you're left with 4x equals 16. Now we've still got this multiplication problem to deal with, right? We dealt with the addition. We don't have to deal with that 9 anymore, but we've still got 4 times x. So in order to undo that multiplication by 4, we divide by 4. And so then you get that 4x divided by 4. Well, that's 4 over 4. Those two will just cancel out and leave you with a 1. So you're left with 1x, so just x. And that's another note I should have said before, that if you've got like 1x, you don't have to write the 1. You don't have to write in multiplication by 1. You can just write x. So on the left-hand side, we've got 4x divided by 4. So that's really what's going on there is, if I write that out over here, what we really have going on is that 4x, that's x times 4, and then we're also dividing by 4. That's what's happening over there, right? So if we've got x times 4 divided by 4, well, if you take something and then you make it 4 times bigger and then you make that thing 4 times smaller, you're just going to get what you started with. So x times 4 divided by 4 is just going to be x. So that's what we're going to get on the left side. And on the right side, it's just a standard division question. So that's 16 divided by 4, which is 4. So you get x equals 4. And then here you can plug this x equals 4 back in right there. So make it 4 times 4 is 16. 16 plus 9 is 25. So you have a 25 on this side, you have a 25 on that side, and you're good to go. Now here's one that's slightly harder because we've got brackets, we've got a couple more steps going on in here, and we've got slightly bigger numbers. So we start with x plus 5 in brackets times 3 minus 2, right? So that's a lot of stuff to work with on the left side, but if we remember from BEDMAS, we're supposed to do addition and subtraction first when we're trying to isolate the variable. The things that are the last steps in BEDMAS, the AS of BEDMAS, that's going to be the first thing that you deal with when you're trying to work through something like this. So we're going to deal with this subtraction problem here. And you're going to say, oh, but there's an addition problem there. Yes, but it's inside the bracket. So it's actually going to be the last thing we address because it's inside the brackets. BEDMAS, right? It's the first step in BEDMAS normally, so it's going to be the last step that we deal with here. So we're going to deal with this subtraction problem first. So if we want to get rid of this minus 2, you can undo that subtraction by adding 2 back to it. So we're going to do plus 2 on both sides of the equation. So we end up with x plus 5 in brackets times 3 minus 2 plus 2. And this minus 2 plus 2 is going to vanish. That's going to disappear. It's going to turn into a 0, right? And then on the other side, we've got 37 plus 2. So that becomes 39. Now the next step, I've kind of, because we've got a slightly longer problem, I've kind of smushed a couple of the steps together. So this minus 2 plus 2, that just disappears. This whole thing is just gone. So now we have this x plus 5 times 3 is what we have in the black text over here. But we want to get rid of this multiplication by 3 business, right? We've got x plus 5 in the brackets. We're going to handle that at the end because it's brackets. So we have this multiplication by 3 to deal with. So we undo multiplying by 3 by dividing by 3 because it's the opposite operation. So that's what this division by 3 is doing. And then same thing on the other side. If we're dividing by 3 on the left, we have to divide by 3 on the right. So if we go through that, this times 3 divided by 3 is going to vanish. So that's going to disappear. And that 39 divided by 3 is going to be 13, right? On the right side. So what that gives us is this. So on the left side, that times 3 divided by 3 vanished. So we're left with just this x plus 5 right here in the black. On the other side, 39 divided by 3, that's 13 in the black. Now we've got x plus 5, and we want to get rid of the plus 5. So we subtract 5 from this side. So x plus 5 minus 5, plus 5 minus 5 is nothing. So we're going to be left with just an x here. And then on the right side, 13 minus 5, that's going to give us 8. And so there you get an answer of x equals 8. And then here you can double check that you got the right answer by plugging this 8 in right up there in our original question and see if this left-hand side comes out to being equal to 37. So 8 plus 5 is 13. 13 times 3, you can do that by long multiplication if you need to, but 13 times 3 is 39 minus 2. 39 minus 2 is 37. So we've got the right answer here as well. So that's everything for today, guys. I hope this lesson made sense. I hope I'm not going too fast. If I'm going too slow, let me know, but definitely if I'm going too fast, let me know, because I don't want to run away with it and leave some of you behind. So yeah, I hope that makes sense. Let me know, as always, if you have any questions. I'm available if you guys need any extra help, or if you have some doubts, or if you think I said something wrong that you didn't quite, No, I think that's not how you work through this question. Anything like that, just let me know. But otherwise, I will see you all in the next video. Have a good one.